All right, so let's go ahead and get started. We're going to be walking through the hypothesis testing worksheet, and I'm going to be showing you some example ways that you can answer the questions and what the questions are sort of geared towards, and where in the PowerPoint you can get the relevant information that you need to answer certain questions. So this is your hypothesis testing worksheet. This counts as a lab activity. I think it's actually the third and last lab activity of the semester. There are only a few of them. So this one is to make sure that not only do you understand the content from hypothesis testing, you can apply it to an idea of your interest, possibly your research project. That would be perfectly fine. The idea is that hypothesis testing is very conceptual and very theoretical, and it applies to any analysis that you can do. So the idea is not just to understand it in abstraction, but to understand how it would apply to an actual idea that you might come up with. So first off, think of a research idea that interests you, can be your group project topic. You don't really need to spend too much time explaining this. It can be really basic. So my basic example that I'm going to be using to walk through these questions with you is, let's say I'm very interested in a variable or construct called meaning in life. This is a variable that basically captures the extent to which people perceive their life to be imbued with purpose and significance. Apropos. So it's a variable that I really am interested in. And perhaps based on my reading, I know that meaning in life is associated with a lot of well-being outcomes, as well as some health outcomes, some actual tangible health outcomes. So let's say maybe I'm interested in how meaning in life is associated with stress. Okay, so there you have it, my basic idea. I'm naming my variables and I'm saying I think that they're linked in some way. So formulate a hypothesis keeping in mind the guidelines of what makes a good hypothesis. What is the alternative hypothesis and what is the null? So in terms of formulating your hypotheses, the area of the hypothesis testing PowerPoint you're going to want to head to is going to be more towards the beginning. So for example, this slide on what makes a good hypothesis. Hypotheses are basically prediction statements. A good hypothesis should be concise and declarative. It is the prediction that you are making in terms of what you believe will happen. It's not a question. It's not a theory. It's a specific prediction that you have identified that you will be testing. It should be brief and to the point, and it should be something that you can test. So what do I predict about the relationship between meaning in life and stress? Well, I think they'll be associated likely negatively. As meaning in life increases, maybe I think people feel less stressed out. So to construct a good hypothesis and to answer the part of the question asking you to identify what constitutes a good hypothesis, this slide right here covers some of the basic guidelines for creating a well-written and effective hypothesis. In terms of this part of the question on the alternate versus the null hypothesis, likely you're somewhat familiar with these concepts already, but in order to revisit that in the hypothesis testing lecture, this is definitely going to be in that first step, this construct your hypotheses point. That's where I cover this alternate versus null hypothesis. The basic distinction is that you want to create two competing hypotheses, one that is the prediction that you're hoping to find versus the hypothesis that you're hoping to find evidence to contradict. The alternate hypothesis, also called your research hypothesis, is what you specifically are hoping to find. The null hypothesis just gives you a baseline of what you're trying to demonstrate evidence in the contrary of. So if you want to know this distinction between alternative and null, that's here in that first part of the lecture where I go through the steps on constructing hypotheses. How would I answer my question here? Formulate a hypothesis, keeping in mind the guidelines of what makes a good hypothesis. What is the alternative? What is the null? I'm going to shorthand meaning in life to MIL. Is negatively associated with stress. So as meaning in life goes up, stress goes down. If you're predicting your two variables to be positively associated, then you would indicate that. So that's my alternative hypothesis. My null hypothesis needs to be the logical counterpart to my alternative hypothesis. So let's see. The complete logical counterpart to meaning in life being negatively associated is that meaning in life is either not associated or positively associated with stress. And then what makes a good hypothesis? Brief, testable, only says one thing, etc. So written into what I've created here is what we call a directional hypothesis. I specifically said I think meaning in life is negatively associated with stress. And so the null has to be the complete logical counterpart to that. If I was formulating what we call a non-directional hypothesis, it would be more so a statement saying meaning in life is associated with stress, but I don't know if it's positively or negatively. You would be willing to accept a correlation that's either positive or negative. Then your null would just be the logical counterpart to that, which is the absence of a correlation. So definitely make sure that you're going through the slides carefully to identify whether you're using directional or non-directional language and formulate your alternative and null hypothesis appropriately. What's one way I could test my hypothesis? We can keep it simple. A series of self-report scales. Participants answer questions about their perceived meaning in life and indicate how stressed they have been feeling. I'll run a correlational analysis. Easy as that. All right, so then identify all the possible outcomes that could result from your research study by filling out this chart. In order to answer this question appropriately, the part of the PowerPoint you'll want to visit is going to be in this decision rule part where I discuss all possible hypothetical outcomes. If you've ever heard of type 1 versus type 2 errors, this is what this question is getting at. To do hypothesis testing correctly, you want to identify all possible outcomes that could result from your analysis. So the idea is, based on the logical parameters that we've set for ourselves, there are a few constraints to what can reasonably happen. One is that we're either going to find support for there being an effect, i.e. a correlation, or we're not. And the data is just going to speak for itself. And it is also the case that we might be right and we might be wrong. We want to basically break down all of the possible logical hypothetical outcomes, because what we're ultimately doing in hypothesis testing is quantifying the likelihood of landing in any one of these quadrants. The whole process of statistical significance testing and p-values is to try to ensure that we're holding ourselves to rigorous standards such that our likelihood of ending up in one of these mistaken conclusion quadrants is as low as we can get it. So how do you actually fill out this quadrant? Think of all possible outcomes that could result from your research study by filling out the chart. So the basic idea is to create a statement reflecting what we would have found should we land in any one of these hypothetical quadrants. So let's start with our correct decision quadrants. So if we end up in this quadrant where we're making a correct decision about there not being an effect, the idea is we need to put this into the context of the variables that we've identified. So what this quadrant represents is correctly identifying that there's no relationship between our variables. So that's a good thing. We like being right. It's disappointing not to find the effect that you want, but better to be right than wrong. If we're living in this quadrant, which is what we want, I find that meaning in life and stress are correlated, and I was correct. Yeah, awesome. That's what you want. Fix that typo so it doesn't drive me crazy. So basically, if we come to the correct conclusion, our ability to know with any amount of certainty that we're right versus we're wrong, these are the logical realities that would be possible if we assume we've made a correct decision. And again, reading the chapter and going through the PowerPoint and waiting for my audio lecture will sort of flesh out your understanding of what I mean by the likelihood of landing in one of these quadrants. But this is basically how you answer this question. So then we have to deal with our type 1 and our type 2 error quadrants. We don't really want to live in either one of these quadrants, but one of them is actually a little bit less pleasant than the other. So let's say we're living in this type 1 error. So we reject the null hypothesis, find an effect, and we are mistaken. So we don't like that. We don't like making mistakes no matter what. But if we're rejecting the null hypothesis, and that is not true about the world, that basically means we're finding an effect where there is not one. And that's pretty bad. If you sort of pull the trigger and say, oh, look, I found an effect on the strength of my data analysis and you're wrong, that's kind of a big deal. That's the sort of thing that gets you into like, oh, I need to have my publications retracted because I made a mistake and I put something out in the world that shouldn't be there. So false positive, we don't like that. We don't like that at all. So we reject the null hypothesis, but we're wrong. So I find that meaning in life and stress are correlated, and I am mistaken. Oh no, that's bad. We don't like that. So that would be one possible logical reality. Should we conclude that we will reject the null hypothesis, there's always the risk that we're going to be wrong, and that's a bad thing. That's why we do hypothesis testing. We want to make sure that we can quantify our likelihood of making this particular kind of error because it's pretty bad. Now, what's a type 2 error or your false negative? This is when you fail to find an effect that's truly there. It's still a mistake, and it sucks to not find an effect that's really there for whatever reason. You didn't have enough participants in your sample. You used a flawed approach for analysis. Flukes happen where just for some reason your particular analysis didn't find an effect that should have been there. That's bad too, but it's not, I'm gonna have to get a paper retracted level of a mistake. It's just you failed to find something that was there, and then hopefully the next project, the next analysis you do will yield an outcome that is truly reflective of an effect that exists out in the world. But what happens if I'm living in your type 2 error quadrant? I find that meaning in life and stress are not correlated. And I was wrong. Good luck next time. Okay. So that's basically how you fill out this quadrant. You basically have to identify what any of these quadrants would look like using the example that you identified and plug it into the language of correct versus incorrect decisions and what that would mean for the conclusions that you make. So that's a kind of a tough question. Definitely visit the slides around here where I discuss decision rules and just plug in your example using this basic sort of language. All right, so then these last two questions are pretty conceptual. They're meant to get you thinking about what does statistical significance mean and force you to understand that p equals 0.05, which I'm guessing you've all have heard that there's something special about p equals 0.05. Why is p equals 0.05 associated with this idea of statistical significance? What does it actually mean? Put it into probability terms. So I discuss this idea of what p equals 0.05 means when I talk about applying the decision rule, the whole idea of regions of rejection, thresholds for statistical significance. Use these last few slides to try and help yourself answer that question. Then lastly, this question about what's the difference between a one-tailed and two-tailed test, and which one would you choose for the hypothesis you created? You're going to want to revisit the earlier slides when I talk about constructing hypotheses, where I discuss this directional versus non-directional distinction, and apply that to one-tailed versus two-tailed. Most basically, if you use a directional prediction, you can use a one-tailed test. If you're going non-directional, meaning that you're not sure if your correlation is going to be positive or negative, you use two-tailed. But what I would like you to do is think about why directional hypotheses apply to this one-tailed, two-tailed distinction for statistical significance assessment. So that's most basically how you can complete this worksheet. By having the lecture slides in front of you, you should be able to answer these questions. Again, if you wanted to wait a couple hours for me to post the audio lecture, that will obviously flesh out some of the material in the slides, but this should basically give you an idea of how you would answer these questions in order to get credit for this worksheet. Okay, so at this point, I'm done discussing the worksheet, and I'm willing to take any questions and or have check-ins if that is what you would like.